Welcome to this video on the evolution of AI coding tools. We will track their journey from simple code completion to today's autonomous development agents. The big picture is that AI coding tools have moved from simple helpers to sophisticated development partners. Key transformation areas include speed, intelligence, collaboration, accessibility, and integration into the full workflow. We can categorize this evolution into 5 distinct eras, starting from the foundation era in the 2000s and culminating in the current agentic era, which features autonomous AI developers. Our journey begins with Era 1, the foundation era, spanning from the 2000s to 2015. In the foundation era, tools like IntelliSense and Eclipse Content Assist established the building blocks. They provided rule-based code completion based on syntax. However, they lacked context awareness and could not understand developer intent. Next came Era 2, the ML era, covering the years 2016 through 2020. The ML era saw a breakthrough as developers began training neural networks on massive code repositories. Tools gained context awareness, offering statistical predictions based on surrounding code, not just syntax. Pioneering tools in the ML era included Tab9, which was the first ML-powered tool to achieve mainstream adoption, and Kite, which focused on context-aware completions. This brings us to Era 3, the Codex era, a transformative period from 2021 to 2022. The Codex revolution was a game-changer. OpenAI's Codex could understand natural language and generate entire functions, fundamentally changing the interaction from typing code to describing intent. GitHub Copilot was the first mainstream Codex application, quickly attracting over 1 million developers. Its capabilities included whole function generation, documentation, and translating natural language into code. Early adoption of these tools faced significant challenges, including legal and licensing concerns, issues with code quality, debates over the impact on learning, and enterprise security worries. Following the Codex revolution, we enter Era 4, the integration era, from 2023 to 2024. The integration era saw the market explode with major launches like Amazon Code Whisperer and Google's Gemini Code Assist. The focus shifted to finding the best AI for a specific workflow. Key trends during this era include deep IDE integration, chat interfaces for conversational coding, increased context awareness across the entire codebase, and the introduction of enterprise-focused features. We are now in Era 5, the agentic era, encompassing 2025 to 2026. The agentic era marks the shift from Copilot to autonomous developer. AI agents can now plan implementations, edit multiple files, use tools, and iteratively solve problems without constant human supervision. Leading tools in the agentic era include Cursor, Replit Agent, and Devin. Devin, for example, is described as an autonomous AI software engineer capable of operating independently for hours. Developer adoption has been massive, skyrocketing from about 1 million users in 2021 to an estimated 75 million or more by 2026. AI coding tools have become the standard. Adoption rates are highest among students, data scientists, and junior developers. These groups use the tools as an accelerator for learning and efficiency, while senior developers use them more selectively. Research confirms substantial productivity gains. Studies show task completion is 35 to 55% faster, and time spent searching is significantly reduced, especially for routine coding tasks. AI tools excel at repetitive, well-defined tasks like boilerplate code generation, writing unit tests, and documentation. However, humans are still necessary for complex system architecture and creative problem-solving. Ongoing concerns include fears about job security, the risk of technical debt from suboptimal AI code, potential over-reliance on the tools, security vulnerabilities, and unresolved legal questions regarding copyright. Enterprise adoption typically moves through phases, starting with a small pilot, expanding to a limited rollout, moving to broad adoption, and finally optimization with custom models and internal fine-tuning. AI is changing computer science education. It accelerates learning and reduces frustration, but educators face challenges in designing AI-proof assessments and preventing over-reliance on generated code. Looking ahead, we can expect more autonomous agents, specialized domain-specific AI, real-time collaboration with AI team members, and security-first models for vulnerability detection. The key takeaways are clear. AI coding tools have rapidly evolved, achieving widespread adoption and delivering real productivity gains. The job is changing, with developers becoming AI supervisors and architects. To succeed, you must learn the fundamentals, use AI tools strategically for boilerplate, always understand the generated code, and develop sharp prompting skills. Focus on human skills like collaboration. The future of development is an elevated profession. The best developers will be those who master both traditional programming fundamentals and the art of AI collaboration. Keep learning, keep experimenting, and keep building.